So yeah, this is a shortcut. So you've tested on Riemann sums, and a lot of you did very well. We have that long limit process.
Oh, no, that's good. I'll tell you.
Okay, all right. So now we're down to using this fundamental theorem of calculus, which makes this a whole lot easier, gives us a shortcut. So based off of the note card that you just wrote, what would I need to do with x cubed? Take the antiderivative.
Be 1/4 x to the 4th.
Okay, so 1/4 x to the 4th. And then we'll go ahead and do the plus c for now, and I'll show you why we do not have to continue doing that. And then we're supposed to evaluate this at 1 and at -2. Well, we jumped right in and started applying the fundamental theorem of calculus, but did you check the condition of the fundamental theorem of calculus? What is that? That condition is it has to be continuous. And some of us already did check that. Is this function continuous from here to there?
Yes.
Great, so then this does apply. And now if we were to input 1 into this function, what will you get?
1/4 plus c.
Plus c. And then from that value, you are to subtract what you get when you input -2.
Because it's subtraction.
Yes.
64 minus c.
And you get what?
64 plus c. Or minus c.
Ooh.
64 plus c.
Did you do
Times 0.25. Oh, wait.
2 times 2 is 4, 4 times 2 is 8,
Yeah,
8 times
I
2 is
did it.
16?
I
This
did
would
it
be
to
4,
the
right?
end
But,
instead.
yeah, so it's 4.
I did that in my head. I'm so happy.
Plus c. And now what's going to happen to those c values?
Cancel
They're
out.
going to cancel out, and we have 1/4 subtract 4, which is,
Negative
3.75.
3.
okay. And was that easier than our limit
Yes.
summation? Mm-hmm. All right. Jordan, you with us?
Yes.
Did they put trig into this?
Yes. Yes, we definitely put trig in this. I'll wait till the next example to do that.
Yeah, yeah.
I can't wait.
Okay? So, what will we do first?
Check and make sure it's
Check.
continuous.
Check first to make sure that it is continuous. And of course it is, it's a polynomial. What's true about all polynomials?
They're all continuous.
They're all continuous, okay? So integrate. Do I need to include the plus c?
No.
No, because it is going to subtract out. So to save us some time, we're not going to include plus c.
It's just
Well, now we'll evaluate this at 2 and at 0. 8/3. Subtract,
0.
which is
8/3.
8/3. Yep. Because you're so in love with trig,
Is that a 6 or a B?
that's a b.
Okay.
So now let's take the integral from 0 to b of cosine of x dx. What am I supposed to check first?
Make sure it's continuous.
Is cosine continuous?
Yeah.
On the entire number line, so doesn't that make it continuous from 0 to b?
Yeah.
Okay, so we need to integrate. What do you get when you integrate cosine?
Sine.
Okay, so this becomes sine of x evaluated at b and at 0. So that'll be sine of b, subtract sine of 0. We don't know sine of b, that's just an unknown variable. What's sine of 0? 0.
Oh, is this? Oh, yeah.
Sine of
Yeah.
So this would just simplify to be sine of b.
Okay, so this is really simple so far. Is it really getting harder?
Well, considering that the rest of the course is about integration,
Oh, never mind. Guys, you answered it.
it will get a little bit more complicated, but the good news is we don't have a chain rule, a quotient rule,
Oh, okay.
a product rule. We don't have all of those rules for integration. Okay?
That's
All right.
not continuous.
Oh, Bennett, say again.
That's not continuous.
This is not continuous. Can you take the antiderivative of this? Absolutely, you can. But does the fundamental theorem of calculus apply here?
No.
So this does not exist. What is the meaning of a definite integral? The area under the curve, the area bounded by the curve. Well, this curve 1 over x squared looks like this.
Wouldn't that be?
Is there an area bounded by this curve going from -1 to +3?
No.
No, that region is not bounded. so you can't calculate the area. But what if I ask you to find from 1 to 3? Yes, this one will have an answer. How would I rewrite that to be able to take the antiderivative of it? X to the negative 2. So then when you add 1, we get negative 1. And evaluate this then at 3 and at 1.
Would be 1, negative 1.
Which would give you
Ooh, 2/3.
2/3.